Connected particles test 1. So this was the first question I gave you. Now, if we're looking at the system, there's rotation about that pulley. So that means that that block is going to slide in with acceleration A, and everything on the right-hand side is going to slide down with acceleration A. Because of the rotation of this pulley, these are going to have accelerations as well, where that will have a different acceleration to A, so let's call it B, and the 2m and the 3m have the same acceleration. All right, when you're filling in your force diagrams then, if it's got a mass, it's got a weight, just multiply its mass by g. If it's resting on an object, the object is pushing back in it, so there's an R there. And also if there's a string attached to it, there's a tension acting on the particle along the path of the string but away from the particle. Put the 7m in there. It's got one acceleration, which is just A. So I always draw the forces and the accelerations next to each other. Here then, this is the 5m pulley. So the 5m pulley has got an acceleration downwards. If it's got a mass, it's got a weight. The string that's attached upwards is also attached to the 7m, so same string, same tension. So that's T. And then you have a string wrapped around it there. That's a different string to that one, so there'll be a different tension. And because that's pulling the pulley on both sides, you'll have two S's downwards. Let's have a look at the 2m. If it's got a mass, it's got a weight. There's a string attached to it, and that string is the same as the one attached to that pulley. So there's a force upwards. We need the accelerations now. So all of that side is going down with acceleration A. So all three of those are going down with A. But the 2m is also going up because of the rotation of the pulley above it. All right, finally then, got a mass, so it's got a weight. There's a string attached to it. That string acts away from the particle along the line of the string, and that's the S there that's attached to that. And then the accelerations, all of the side is accelerating down with acceleration A, and this one is also accelerating down because of the rotation of that pulley. So we'll have B downwards. Now that's the first part of it, just to give you an overview there. Let's now have a look at the formula that you're going to use. So first of all, there's no acceleration vertically there, so those forces have to be equal. So up and down for that one, R equals 7mg. I'm basically saying that that force minus that force equals 7m by the acceleration, which is 0. And when you rearrange it, you get that. And then to the right, we have one force causing that acceleration. So right and left, we'll have T is equal to 7m as the mass multiplied by the acceleration. This one. Okay, so I'm going to say downwards is positive here. So any force downwards is positive, any acceleration downwards is positive as well. Anything upwards would be negative then. So I'll have 2s and 5mg downwards. T is upward, so I put a minus in front of that, and that's equal to the mass of it, which is 5m, by the acceleration is also downwards. So that's my second equation. In this case, pick a positive direction. It doesn't really matter which way. I'm going to say down, up is negative for that one. So that'll be positive. The S is in the opposite direction, so that's a minus. The mass is 2m, and now one acceleration is downward, so it's positive, the other one is negative, so I'll have A minus B. The last one, pick a positive direction. I'm going to say downwards is positive for that one as well, and negative is upwards. So 3mg is positive, minus S, because that's in the negative direction, and both of those are downwards, so you get 3m into A plus B. You should be able to solve them yourselves.